Alright, this is going to be Algebra 2. We are on Unit 4 Pretest, going over some of the ones that we got wrong or just have questions on. So let's get started. Oh, by the way, do we want to say hi, Claire? Wish you're feeling better? Alright. We all hope that you're feeling better. So number 2 is the first question. So 1 over a to the power of negative 1/3. So this rule is using a negative power and a fractional power at the same time. So the general rule is if I have any a to the negative power, it could be -2, -1, that will turn into 1 over a. So essentially flip it and then make the power a positive 1. So in this problem I have 1 over a to the power of negative 1/3. I'm kind of rewriting it needlessly. That's going to turn into, I'm going to flip it, so if I flip it, it's a over 1, and now it's to the power of 1/3. So I flip it and then keep it to a positive power instead of a negative power. So this is really the same thing as just a to the 1/3. So the next question is, what happens when you have a fractional power? Well, fractional power, so say if I had a to the 1/2, that would turn into the square root of a. This root here is whatever was in the denominator, and this 1 is in the numerator, so that goes here. So if I had a to the 4/5, that will turn into a to the power 4 and then the 5th root of that. And that's the same thing as writing the 5th root of a, all of that to the power of 4. It doesn't matter the order. So that's kind of the rule I'm using here. So once I have this step, then I say, well, that's the cube root of a. The correct answer is D. All right, moving on to the next question. Unless you guys good? Yeah. Okay, perfect. Number 5 was simplifying this one, and as Ben pointed out, the correct word would be what is equivalent to, because in our class we don't like negative powers. We assume simplification actually means get rid of the negative powers. So which of these is equivalent? So let's go ahead and simplify the inside first, inside the parentheses. So I have a -2, and then this, if this is x to the 4th, x to the -2, this will be an x to the power of 6. This -2 comes to the numerator and becomes positive, so 4 plus 2 is 6. What's going to happen with the y's? So this is a -1. If I bring it down, then it's going to become positive, so this is going to be divided by y to the power, I'll remember the 5 in a sec, the y to the power of 5. So that gets rid of the y's, leave the 5 in the denominator. So I've simplified inside the parentheses. The y came down to become positive, x came up to become positive, getting rid of those negative powers. From here, I need to apply the cube to all these numbers. -2 cubed, again, the negative doesn't go away because this is an odd, not an even. An even would make this a positive, so I still have my -8. And then x to the power of 6 to the power of 3, so I multiply these. 6 times 3 is 18, so this is x to the power of 18. And 3 to the power of 5 is 125. And y to the power of 5 to the power of 3 is going to be y to the power of 15. And where is this one located? Oh, we have to have a negative power, so sorry, let's change that once again to, I still have -8 over 125, and they don't do this, so it's still x to the 18, and now this is gonna, we'll bring the y up to be a y to the power of -15. I was simplifying, I forgot that we're just finding an equivalent form, and there it is, B. We have that negative in there. In fact, once we realize that this is a negative cube, you could have eliminated all the positive ones just because they're positive. So that would have been a really quick shortcut. Yeah, questions? We're good? All right. Moving on to number 28 and 29. All right, so sketch an example of growth or decay, and this one you don't even have to be that exact. For my solution, I said, okay, well, I'm going to go through somewhere on the y-coordinate, and I actually chose a rate. I said maybe it'll multiply by 2, so 1 times 2 is 2, 2 times 2 is 4, and that keeps going up, so this was going to be a half. And I actually made something that looked like this, but even if you have a general line, it'll be fine as long as it goes up and up forever towards the right, And the most common error was just kind of stopping right here at the y-axis. Make sure that it goes all the way and continues on with a horizontal asymptote that gets closer and closer to 0. Oh, wait. Yeah, closer and closer to 0. I thought it was 1 for a sec. No, it's 0. So this is exponential growth. Make sure you have this left end of the curve. And then for number 29, this is going to be exponential decay. It's basically the same thing, and I'll go really quick. And you can just say, okay, it looks roughly like this, and it goes on and on forever this way. I didn't even have to plot points. I'll still give you points. I want to know roughly what does it look like. It did say sketch. It didn't say graph. So when you see the word sketch, come on now. That means just roughly give me an idea what they look like. Don't forget that horizontal asymptote. All right, so number 30. We know a bunch of information. This is kind of just remembering what goes where. So treasury bond, $500, that's the principal. 500 goes in for P. 5.5%, once we convert it to a decimal, that is going to be our R. 50 years, that's going to be our T. So you literally just plug all those in. So your correct answer should be A is equal to 500 times 1 plus, and then remember that the rate is just this number converted to a decimal. Don't add 1 to it. It's just 0.055 as a decimal. Leave the 365 in the numerator or in the denominator, and then we have 365 again. Both these numbers happen to be the same, or they're always the same, and I multiply this by 50 years. I assume that T is the number of years. It doesn't really assume that in our equation, but I think we can make that assumption. All right, questions on number 30. All right, moving on to the last question that we had. Number 32. So this guy. So this can be treated as two parts. The first part is talking about these numbers. The second part is talking about the e's. So in terms of the first part, 9 divided by 3, that's just 3. Now this part, e to the power of 3/2 divided by e to the power of 1/2. Whenever you have the same base, I do have the same base, e, then this division problem means I'm going to subtract the powers. So this is 3e to the power of 3/2 minus 1/2. That will turn into, so this becomes, again, we have our 3, and this is going to be still e. Don't mess up for the e. 3/2 minus 1/2 is 2/2. And that will turn into just 3e. So 3e to the power of 1. All right, and that's our final answer.